Welcome back to the channel, everyone. In this video, I'm going to record myself attempting this math AASL paper from the most recent November 2021 sitting. It's a paper one, so the non-calculated paper. And apparently the gray boundary of this paper is much lower than the usual gray boundary, which is like what, high 70s, low 80s for a 7. And my student would like to see if this paper is indeed much more difficult than the usual papers that we have encountered in the older syllabuses, because this also is the only the third paper released for the current syllabus. So without further ado, let's just jump into the paper, and I would like to finish this as quickly as I can, hopefully within 30 to 35 minutes. Question 1 is a quadratic function question, which should be fairly straightforward. They give you the factorized version. For the graph of f, find the x coordinates of the x-intercept. So basically, these are the roots, and you can find the roots by just setting the entire thing to equal to 0. So we have x minus 1, x plus 3, I guess negative 2 in front as well, equal to 0. So x equals to 1, or x equals to negative 3. A2, find the coordinates of the vertex. So for this, you can expand and find the put this into vertex form by completing the square. I'm not going to do that because there's an easier way. Just recognizing that the symmetry element within a quadratic function should allow you to recognize that the line of symmetry will be x equals to the midpoint between the two roots. So it's negative 3, the midpoint between negative 3 and 1. So that's just negative 1. And then the corresponding value, the y coordinate, can be deduced just by plugging x equals to negative 1 into the original. So this equals to negative 2, negative 1 minus 1, negative 1 minus plus 3. So negative 2 times negative 2 times positive 2. So that should be 8. And then the last part, the function f can be written in the form. So they actually ask you to complete the square. There's no need to re-expand and complete the square when you already know the coordinate of the vertex, because you can just directly recognize that. This is the h, and this is the k. So that's it for the first question. Moving on, let me change my view mode fit to width scrolling. Question 2 is about some integration. And you probably need to find the c value. So dy over dx is cosine of a linear function. Therefore, y would equal to the integral of the function. Now, when you integrate cos, you get sine. The content of the trig is unchanged for now. And this is a linear composite. So strictly speaking, you need to multiply by 1 over the coefficient of the x within the linear composite, because there's a what reverse chain rule, or integration by substitution would lead you to, but then here 1 over 1 is just 1, so I'll just drop that. What you must not drop is the constant of integration, which can be determined by plugging a point that's given. So we have 2 equals to sine bracket 3 pi over 4 minus pi over 4 plus c. 3 pi over 4 minus pi over 4 is 2 pi over 4, and that's just pi over 2. Pi over 2 was 90 degrees. Sine 90 degrees 1. C equals to 1. Therefore, y equals to sine bracket x minus pi over 4 plus 1. That should be it. I didn't copy and I didn't paste the answer to the first question, but it doesn't really matter. You guys can always scroll back, like rewind the video to the correct point just to like investigate. Question 3, some reciprocal functions, so pretty standard stuff. The vertical asymptote of a linear reciprocal function is just given by this. The horizontal asymptote, meanwhile, is given by the ratio of the leading coefficients. Find the coordinates where the graph of f crosses the x-axis. So to find the x-intercept, we set y equal to 0. So when y equal to 0, we basically have only the numerator equaling to 0. Y-axis, we set x equal to 0 instead. Y equals to 0 plus 4, 3 minus 0 equals to 4 over 3. But actually, I did a pretty bad job in spacing out my paint, so let me just fix this first. Okay, question 3. So you have to sketch the graph. Only for 1 mark on the paper 1. That's kind of stingy. Sketching the graph should not be too difficult because once you have established the framework for the graph, it should be easy to fill in the rest of the graphical details. Of course, you do need to know the general shape of these kind of reciprocal graphs, which either be this orientation or the other orientation. The asymptotes and the intercept should guide you to the correct decision regarding the orientation of the linear reciprocal graph. If we graph the asymptotes first, is y equal to 2? Wait, my bad, it should be y equals to -2. And x equals to 3, so over here. The intercept x equals to -2 is over here. Y equals to 4 over 3. It's like here-ish. So the general shape should be like this. Okay, could have shown the graph with better curvature. So that's one branch. The second branch, some people just like to casually draw something like this. I typically would pay attention to the diagonal symmetry of these kind of graphs. It's usually not crucial for getting the marks, but it just looks more aesthetically pleasing because I have some standard for myself. And well, what's the name of this course? Well, this is standard math, right? Any event, let's move on. Bad pun. Question 4, some probability problems. Probably not too difficult. They give you 2 boxes which are going to be chosen at random, and then the box contents are not the same, so we should definitely proceed by drawing a tree diagram. The boxes are actually 1 and 2. Choosing the boxes randomly means that the probability should be just half and half. They want to note the probability of drawing a red ball by the end. The first one, 5 out of 7. That's technically fine. So the white, which is a complementary outcome, would just be 2 out of 7. While for box 2, the probability should be 4 out of 7 and then 3 out of 7. So P red would equal to P box 1 and red plus P 2 and red over the 2 paths. So these are the 2 paths that I just accounted for. So the probability for each path would be half times 5 over 7 plus half times 4 over 7, and that amounts to 9 over 14. Part B, determine whether events A and R are independent. Well, the answer should be the clear answer should be yes, because if you go for if you randomly pick box 1, then there's a higher chance of drawing a red. There are a few mathematical equations that you can use. Check if P A times P R equals to P A N R. So this is a standard equation that a lot of students use. Not my favorite, however, but I'll use it anyways. Box 1 is chosen as half. PR, we just figured out is 9/14. PA and R. We just calculate the left-hand side and the right-hand side separately because that's the proper way to prove or disprove a mathematical relationship. PA and R is just basically the same as P1 and R. So that's 5/14. They're not the same. Therefore, independent event. Oh, sorry, not independent events. So dependent. And I said that this is not my favorite equation because it doesn't really allow us to understand the meaning of event being dependent. A better definition of event being dependent is that PA should be the same. Actually, it should be PR in this particular, for this particular scenario. So whether you draw, the probability of drawing a red ball should be the same whether or not you draw it from box 1 or box 2. And you can just plug the probabilities into this equation and see that the 3 probabilities are not the same. All right, so next question. Some calculus stuff, I guess. I see the word tangent. The function f is defined by for all real x values, and the line y equals to 6x minus 1 is the tangent to the graph at x equal to 4. So write down the value of f dash 4. And f dash 4 is basically the gradient of the tangent line at x equal to 4. So the answer is just going to be 6. Because the m within y equals to mx plus c of the tangent line is also the derivative. For part B, you have to find f4. To find f4, you have to recognize that the tangent line makes contact with the original graph. So f4 for the tangent line should be the same as f4 for, x equal to 4 should give you a y value. Well, x equal to 4 into the tangent line should give you the same y value as f to the 4. So 23. The function g is defined such that g is a quadratic and h is a composite. H4 equals to f of g of 4. G4 itself is calculable to be 4 squared minus 3 times 4. 16 minus 12, that's also 4. So that's 23. Hence find the equation of the tangent to the graph of h equal at x equaling to 4. This is the chain rule situation. So to find h dash of 4, we have to apply chain rule without the actual functions themselves. So differentiating without the actual function, well, we write f dash of g of 4. So when we differentiate the outer function, the content remains unchanged. And we multiply the first term by the derivative of the inner function. Despite not having the function, I think we have all the values. G dash 4. Well, actually, we do need to differentiate this. So the derivative of g at 4 is just 2 times 4 minus 3. F dash of g of 4. So f dash for g of 4 is 4 itself. And f dash 4 is 6. So the equation is going to be y equals to mx plus c with m equaling to 13. On the contact point, x equaling to 4 and then y equals to 23. I think c equals to negative 97. Y equals to 30x minus 97 would be my answer. Slightly tricky. But this kind of question like shows up a lot where there's minimal algebraic differentiation, but understanding how to apply chain rule, product rule, quotient rule, that kind of stuff without actual functions has shown up quite a bit recently. Okay, question 6, some algebra stuff. I'll just do on this base. So 2x minus 3 minus 6 over x minus 1 can be put together into a single fraction. 2x minus 3, x minus 1, all minus 6. And if you expand the top, what do you have? 2x squared minus 5x plus 3, and then minus x. And then 3 minus 6 is minus 3. And then the second part, so we have a trigonometric equation that is somehow related to part A. Clearly, we can just let x equal to sine 2 theta. Then the result in part A using the result from part A, I should say. So this entire thing is analogous to this with x replaced by sine 2 theta minus 1, and we can replace it by the right-hand side. So 2 sine square 2 theta minus 5 sine 2 theta minus 3 all over denominator, which is not going to be useful. So all that equal to 0. You multiply the denominator over, it's still going to be 0. The top meanwhile is factorizable quadratic. I'll do this even though if I write the exam myself, I won't do this, but for students who are not familiar with this, I guess I could have just used x already, but guess what? I'll just factorize it in terms of sine theta. So it should be 2 sine theta. Oops. It should be a trivial quadratic to factorize. I think this should be minus 3 and this should be plus 1, because this way you get minus 6 sine theta plus sine theta to satisfy the 5 sine 2 theta, negative 5 times sine 2 theta in the original numerator. Wait, it's actually 2 theta, my bad. Two sine 2 theta plus 1 equal to 0. So sine 2 theta equals to negative 1 over 2. Well, that's interesting. But the second one should not yield any result because sine 2 theta equaling to 3 is not possible. If we try to solve 2 theta, the original given range is from 0 to pi, but that's for theta only. So we multiply by 2 throughout. 0 less than 2 pi, 2 theta less than 2 pi. So we use a unit circle and recognize that the sine theta equaling to negative 1 should give you 2 theta equaling to the third and fourth quarter version of 30 degrees, because sine 30 degrees is positive half. The third quarter and fourth quarter version of 30 degrees is 210, which is 7 pi over 6, since we are dealing with the radian mode answers. 330 is the fourth quarter version of 30. The radian mode answer is 11 pi over 6. So just divide by 2 throughout theta equals 7 pi over 12, or 11 pi over 12. And that brings us to the end of section A. So now on to section B, where we have longer questions. Some kinematics question at first. 7 markers already on a kinematic that's only based on a quadratic, so the algebra cannot be too demanding, I guess. VT relationship, so V is a negative quadratic, and they're asking for maximum velocity. To find the maximum velocity, we have a choice of completing the square and then noting the vertex y value. Well, -3 is an odd number, so I think maybe differentiating and setting the resulting derivative to equal to 0 will be easier. So setting dv over dt to equal to 0. So 4 minus 6t is a derivative of vt relationship. Setting that equal to 0, t equal to 2/3. And then for part 2, show that the distance of p from O at this time is that many meters. To find the distance, we have to integrate. I'm hesitating because I'm not sure whether this particular quadratic has positive and negative sections, but from the first, during the first 3 seconds. If I try to factorize this first, I'm pretty sure this is factorizable. 3t squared minus 4t minus 4 equal to 0. 3t minus 2t plus 2 equal to 0. So this is a set phase quadratic parabola. And the graph should look like wait, no, I'm pretty sure this is wrongly factorized. Yeah, that's more like it. So this is -2/3, and this is 2. And indeed, the graph will sink into the negatives, but not before the graph reaches maximum velocity. So I guess we can just integrate. So I'm not sure how much these analyses are, how many marks these analyses are worth, but I don't think this work is dispensable. So the distance, displacement, which will equal the distance in this case, equals to the integral from 0 to 2/3, integrating the original. So I'm guessing this is a difficult question, not in the sense that the algebra is challenging, but rather it's like the extra consideration that you have to make before you go and differentiate or integrate. It's challenging. So when you integrate this, you get 4t plus 2t squared minus t, 3t squared, 3t cubed over 3, which is just t cubed. You plug 2/3 and 0 into the thing, and you get 8/3 plus 2 times 4/9 minus 8/27, and it would just arrive at some common denominator. 72 plus 24 minus 8, so I think that's indeed 88/27. 7b, sketch a graph of v against t, clearly showing any points of intersection with the axes. I think I have already done most of that, except that I need to mark the y-intercept, which is 4, and I also need to drop the negative section. It's not really part of the domain. I guess I can add a dotted line just to show what the full parabola will look like. So that's part B. Part C is about the total distance. So by sketching the graph, you realize that the object would have moved forward from 0 to 2. From 2 to 3, however, the object would have moved backward. I probably should have added a vertical line to indicate the end of the time interval. So from 0 to 2, the distance would equal to the integral that we have already evaluated early on. We plug in 2 and 0 as the upper and lower bounds respectively. So we have 8 plus 8 minus 8. So 8 meters. And then between 2 to 3, the displacement should be a negative value. So 12 plus 18 minus 27 minus 8 plus 8 minus 8. So that equals to 3 minus 8, so negative 5 meters. So therefore, the total distance would be 8 plus 5. I like this question. I think this is the interpretation required for getting full marks here. It's not trivial. It's not trivial. In the old days, there were lots of trivial questions in SL paper, and you, like a capable student, should be able to finish SL papers in 30 minutes, I think. Even the May 2021 papers are not as easy as previous ones, which I think is a welcome sign. Well, at least for teachers like me. For students, you guys probably want to have the easier versions. Going back to the question itself, general exponential function, you're looking at 4 equals to a to the 2 over 3. Therefore, a equals to 4 to the 3 over 2, which equals to 8. Write down an expression for the inverse of 8 to the power of x. So this is the original. So you want to find the inverse by reversing the roles of the of the x and the y, and then you make the new y, or which is the old x, the subject. So y equals a log to the base 8 of x, because that's how you invert an exponential function. So the inverse function be log to the base 8 of 8, and it's only worth 1 mark. Part C, f the inverse function. Well, this is log to the base 8 of root 32. And this is best dealt with using change of base. So recognizing that 8 and 32 both belongs to the family of powers of 2. Root 32 can be further rewritten as 32 to the power half. Using log rules allows me to fish out the half and put it in front of the log. Luke. And log 32 is, log to the base 2 of 32 is 5. Log to 8 is 3. So 5 over 6. Part D considers some random looking arithmetic sequence. Show that 27, P, Q, and 125 are 4 consecutive terms in a geometric sequence. So that's interesting. To show that they are consecutive terms in the geometric sequence. Well, first of all, we know that the logs of these numbers are forming an arithmetic sequence. So we can find the common difference first. Or we can let D be the common difference. So D equals to log 8 P minus log 827. And you can use log rules. You can also claim D would be equivalent to log 8 of 1 to 8 P over Q, and then 1 Q over P, my bad. And then in each case, I can unlock both sides. So I'm looking at 8 to the D equals to P over 27. At the same time, it equals to Q over P. At the same time, 125 over Q. And then now we have basically completed the proof, because 8 to the D is a constant. It's the ratio. It's the ratio between each consecutive pairs of terms. Each pair of consecutive terms. n is constant. And that is the requirement for consecutive terms that belong to the same geometric sequence. That should be good enough. To find the value of P and Q, well, you've got 125 being the fourth term of the sequence, so I think we can actually find the value of D first. So 27 times 8 to the D cubed equals to 125. So 8 to the D equals to 125 over 27, which leads, actually I missed the cube. So 8 to the D without the cube equals to 5 over 3 because 125 over 27 is nicely cubitable. We don't actually need to find the value of D. I have no space. Just copy it over. I should write it here. So P would equal to 27 times. Writing in green after writing like my entire thing in red is unsatisfying, but no, I don't care. 45. And then Q would equal to 45 times 5 over 3, which is 75. So that's the answer. Oh, last question is some interesting calculus stuff. Integration without an actual function. Well, this thing is actually a negative power 4 function, but SL, you guys don't need to know about this. Let's address the question first. Find all the values of x within the graph where the graph of f is increasing, even though this is the derivative graph. So f is increasing means that the derivative graph needs to be in the positive. So therefore, the answer should be everything between p to 0. Actually, should be a strict less than, strictly less than, or strictly greater than when you deal with increasing or decreasing functions. We find the value of x where the original graph has a local maximum. So we need f dash to equal to 0. And we also need the proper change sign, a sign change. So, and we need f dash to go from positive to negative. And yes, you can write in English and explaining your answers. The answer should be here. There's only one mark, so but I'm pretty sure you still need to justify your answer. Just for values of x average, so slightly less than 0, the derivative graph is positive. After 0, the derivative graph is negative. And that satisfies this sign change condition. So you have positive sloping graph, and then it goes horizontal at one point, and then it goes downhill from there. Part C, find the value of x where the graph has a local minimum. And this time you have to justify your answer for some reason. And it should just be the exact opposite, x is a p. So the reason will be f dash p is 0 and sign change from negative to positive. I'll use more formal notation. I'll write f dash x instead of just f dash. And then part C2, looking for points of inflection. For points of inflection, we need f double dash to equal to 0 and sign change. And if you construct a sign diagram for the second derivative. Well, the second derivative is the derivative of the first derivative. So at Q, at R, and at T. So these are the points on the first derivative graph where the first derivative graph is horizontal. The second derivative, again, is the derivative of the first derivative. So it was positively sloping, leading into x equal to q. Negative sloping, so negative second derivative between q to r. I should just use positive and negative. Positive and negative inside. F double dash r is 0. And then there's a positive section from r to t. Just the first derivative is positive sloping, means that the second derivative is positive. So at q, r, and t, there are sign changes. So all three are valid points of inflection. And the sign diagram itself is like sufficient explanation. Last part can be challenging. The total area of the region enclosed by the derivative graph and the x-axis is 20. So the idea is that you have to know that when you integrate a derivative graph between 2 points, mostly P0 and T are the interesting points. And then we separately have the integral from 0 to t, also is the same derivative, because f t minus f0. Now the total area is 20. So if we let this area to be a, then this area will be 20 minus a. But then the integral, well, this area is underneath the x-axis, therefore the integral should be a minus 20 instead. So we have a equals to f p minus f0. And over there we have a minus 20 equals to f. Wait, I messed up. It's f0 minus fp. But we have a minus 20 equals to ft minus f0. I think at this point you can just subtract the two equations just to get rid of a first. The left-hand side becomes a minus bracket a minus 20, so just 20. Right-hand side, f0 minus fp minus ft plus f0. Then you look at 20 equals to 2f0 minus, well, fp minus ft is 4, therefore 24 equals to 2f0, f0 equal to 12. So questions like this showed up quite often in some previous syllabuses as well. Again, not much in terms of algebraic integration, but rather understanding the significance of the integral value and area between graph and axes. And I think that's it for this paper. So it took kind of long, but I think I also explained everything fairly clearly. So I don't have the answer key, unfortunately. I would usually tell my student I am the answer key, but well, ultimately it still depends on IB to say whether my answers are correct. In any event, I hope you guys enjoyed this video, and I'll see you guys next time.